Okay, so we have the first of our videos here for hypothesis testing, and we're going to start with learning how to state a null and alternative hypothesis. So let's give a little background information. A hypothesis test is a process that uses sample statistics to test a claim about the value of a population parameter. The main objective of this chapter is to develop the ability to conduct hypothesis tests for claims made about a population proportion or a population mean. In the book, they do talk about population standard deviations, but we're not going to worry about those right now. Again, we are making an inference from a sample to a population. So an example of this is if you're wanting to buy a car and the car they tell you gets 50 miles a gallon. You want that to be true if you're going to make the investment in this car. But sometimes we know people's advertising is not really what's happening. So this is a way, and you couldn't check every car, could you? But you could take a sample of the cars. You could find their mean miles per gallon and find out how close that is to the advertised one. And from there, you could decide with that hypothesis test, you would be able to make a better decision about whether they're telling the truth about how many miles per gallon their vehicles or if the advertisement is correct, is a better way to say it. So later videos, we're going to walk through the steps for conducting hypothesis tests for means and proportions using StatCrunch. But first, we want to be able to state the hypothesis symbolically. So what do we mean by a statistical hypothesis? It's a statement about a population parameter, again, for this course, means and proportions. We're going to carefully state a pair of hypotheses, one that represents the claim, the other its complement. Remember the idea of complements we've talked about throughout the course. When one of these hypotheses is false, the other must be true. Now, that's an argument we can make philosophically, but for the purpose of this course, it's either one or the other. Either hypothesis, the null hypothesis or the alternative hypothesis, may represent the original claim. So how do we state a hypothesis? The null hypothesis, which is H naught, you see the H with the subscript 0, is a statistical hypothesis that must contain a statement of equality. It's either equal to, less than or equal to, or greater than or equal to. And when you're entering these into StatCrunch, you're only going to use the equal sign for the null hypothesis. You won't use the less than or equal to or the greater than or equal to. And we'll see examples of that later. The alternative hypothesis is the complement of the null hypothesis. It is a statement that must be true if the null, H naught, is false, and it contains a statement of strict inequality. So it could be not equal to, it could be less than, it could be greater than. Those are the only options. These are the only options for the null up here, and these are the only options for the alternative here. The symbol H naught is read as H sub 0 or H naught, and H naught is read as, or HA is read as H sub A. It's a subscript of A. To write the null and alternative hypothesis, translate the claim about the population parameter from a verbal statement to a mathematical statement, then you write its complement. That's what we're going to learn how to do here. For a hypothesis test for a mean, the symbolic representation looks like the three cases listed below. And it's either any one of these three. If it's a two-tailed test, it's equal, not equal. If it's a left-tailed test, the null is greater than or equal to, and the alternative is less than. And if it's a right-tailed test, the null is less than or equal to, and the alternative is right-tailed. Those are the only three options. Then if we go on to proportions, it's got to look like, now notice all of these have to be between 0 and 1, so we're using 0.48 for our sample. A two-tailed test, it's equal to or not equal to 0.48. The left-tailed test, 0.48, is greater than or equal to, and the alternative is less than 0.48, and of course the last case. So you notice the way you do this, whether it's a mean or a proportion, it's very simple to they follow the same format, the same pattern for which one of these cases you'll use depending on the problem that you have. So let's look at chapter 5 from the homework that asks us to identify the claim and the proportion. So the claim, they want us to identify the claim, identify the null and alternative hypothesis, and then locate the claim. So for the statement below, write the claim as a mathematical statement. State the null and alternative hypotheses and identify which represents the claim. A laptop manufacturer claims that the mean life of the battery for a certain model of laptop is more than 3 hours. People that use electronic devices know this is a big deal. I had an iPhone that's battery, I don't think, lasted 3 hours once. Anyway, write the claim as a mathematical statement. Well, right here, the claim is what? A laptop claims that the mean life of the battery for a certain model of laptop is more than 3 hours. That would be the mean greater than 3. That's my claim. All right. And that's the symbolic representation. So now I want to take that and use it to create the null and alternative hypothesis. Well, there's no equality in there, is there? It's just greater than. So it's got to be the alternative hypothesis, which we see is the option here with answer choice C. Mu is greater than 3, and up here, mu is less than or equal to 3. The condition of equality must always be in the null hypothesis. So our claim is actually in the alternative hypothesis. And that's what they ask us to do here. Identify which is the claim. The alternative hypothesis, H sub A, mu greater than 3 is the claim. We're going to move on, and we'll be working some of these hypothesis tests and interpreting our results as we go through the next several videos. I'll have another one for you shortly.